In this problem, we're told the tub of a washer goes into a spin-dry cycle starting from rest and reaching an angular speed of 5 revolutions per second in 8 seconds. At this point, the person doing the laundry opens the lid and a safety switch turns off the washer. The tub slows to rest in 12 seconds. Through how many revolutions does the tub turn during the 20-second interval? Assume constant angular acceleration while it's starting and stopping. So imagine this right here is our washer, right? And so we know it's going to be spinning. So it starts from rest, right? And then it's going to speed up all the way to 5 revolutions per second, right? And we know this is going to take 8 seconds, right? And at that point, right, it's going to stop, or it's not going to stop, right? But it's going to start slowing down, right? The person's opening the lid, and then it's going to take 12 seconds for it to all the way, right, to turn and then stop eventually, right? So basically what we're trying to do is find how many times it turns during this interval. So how do we want to do that? So first thing you always do is write down your variables, right? So we know the initial angular velocity, right? So there's two different intervals in this case, right? We have one interval and then another interval. So let's actually just write down given for 1 and 2. So given, this is going to be for 1, which is interval 1, and then given for the interval 2. So what do we know about the initial interval? For the initial interval, right, it's radians per second. It's starting from 0, right? So the initial angular velocity is 0. Why? Because it's starting from rest, right? And then it's going to go for 8 seconds. So the time is going to be 8 seconds. Right, it's going to spin for 8 seconds, and then it's going to reach an angular velocity, omega, of 5 revolutions per second. Okay, and then that's basically it for this interval. And then the next interval, right, we'll say given 2 for the second interval, we know it's going to start with what? So it's going to start when this one ends, which its velocity, or angular velocity, is 5 revolutions per second, right? And then it's going to go for how long? It's going to go for 12 seconds, right, until it slows down to 0. And once it slows down to 0, this is omega 0, by the way, not omega, because this is what it starts at, not what it ends at. And then omega final, right, which we just write omega, what it ends at is 0. Why? Because it's going all the way back to rest. So 0 radians per second, right? So now we've got this information. I always write them as radians per second because when we solve these equations, they need to be in radians per second, right? So time needs to be in seconds. These need to be in radians per second. So we got to convert these first before we solve. So 5 pi revolutions per second. We know that there's 1 rev. 1 rev is equal to 2 pi radians. Right, and if that's the case, we can just write it like this. I'll show you how to do it for this one. So 5 revolutions per second. We know 1 rev is the same as 2 pi radians. Notice the revolutions cancel. 5 times 2 pi is just 10 pi. So it's 10 pi radians per second, essentially. So this is equal to 10 pi radians per second. So all we're doing is multiplying by 2 pi, right? So this is also just going to be 10 pi radians per second, right? And so now we've basically got all variables lined up and we just need to solve. So what are we finding? We're trying to find theta, right? Because theta is the angle at which it turns. But when we solve this, it's going to be in radians per second, right? But then we're going to have to convert it back into revolutions, right? So we want to solve for theta. So we'll just say theta equals question mark. And so how do we do it? So the way we're going to do it is by using rotational kinematic equations, right? So you should remember this equation from kinematics, which is delta x equals v plus v sub 0 over 2 times t. So you can solve for the change in the position if you have the initial and final velocity and the time, right? But in this case, we're trying to solve for theta, right? So theta is equal to omega plus omega 0 over 2 times t, right? So basically just the same equation, but with the rotational kinematic variables instead. And so keep in mind, we have this information. We have omega final, and we have omega initial, we have omega final, and we have t for both of them. So all we have to do is just plug in the information and we can solve for theta, right? So let's just start with the first interval. So for the first interval, we're solving for theta. It's going to be equal to omega plus omega 0. Omega is 5 or 10 pi radians, so 10 pi plus omega 0, right, which is 0. 10 plus 0 or 10 pi plus 0 is 0, or 10 pi dividing by 2, and then we're multiplying by t. So the time this interval takes is 8 seconds. We're just going to cancel this. So 2 times 8 is, or 8 divided by 2 is 4. So this is really just 4 times 10 pi, which is just 40 pi. So theta is going to be equal to 40 pi, right? So it's going to be 40 pi, but this is in radians. So we got to convert into revolutions. So we know that 1 revolution is the same as 2 pi radians, right? Just doing conversions. Radians cancel. 40 pi divided by 2 pi, the pi's cancel. 40 divided by 2 is 20. So it's just going to be 20 revolutions. Right? Because I want to get in revolutions first because that's what they want us to find, right? They want us to find how many revolutions we do throughout the entire interval. So if we know the first interval is 20 and we can find how much they turn in the second one, we just add them up. So this is 20 revolutions for the first interval. So we'll just say 1. Now let's do the second interval. Theta is equal to it's going to be, right, this equation, omega, which is 0 for this one, plus omega 0, which is 10 pi. 10 pi plus 0 is 10 pi. We're dividing by 2 now, and then multiplying by the time. This one is going to go on for 12 seconds, multiplying by 12. 12 divided by 2 is just 6, so we're just multiplying 10 pi times 6. This is just going to be 60 pi, so it's going to be 60 pi radians. So 60 pi radians, once again, we're going to convert to revolutions because they want to know how many revolutions it is. Cancel out the radians, just like here. Now we have it in revolutions. The pi's cancel. 60 divided by 2 is 30. So 30 revolutions. This is going to be how much it turns in interval 2. So now it's saying how many intervals does it turn throughout the entire interval, throughout the entire thing, right? So 20-second interval, right? Adding them up, it's 20. It's just going to be 20 plus 30. 20 plus 30 is 50. So 50, and then it's going to be revolutions. So 50 revolutions, that's going to be how much it turns throughout this entire interval, right? Because you just add up how much it turns in one plus how much it turns in the other. So 50 revolutions, that's going to be your answer to this problem, and hopefully you found this useful.